our next example, whoops, erased a little too much there. All right, our next example is sketching this graph. I have a degree 3 polynomial, so I have to synthetically divide. When I'm synthetically dividing, I need to take this -1 and make it a +1. And then I take all my coefficients and put them here. So this was a 1, 2, well that's a -x, so it's a -1, and that's a -2. Pull my 1 down. I'm going to pull 1 down, okay? 1 times 1 gives me 1. Add down now, 2 plus 1 gives me 3. 1 times 3 gives me 3. Add down, add -1 plus 3 gives me 2. 1 plus 2 gives me 2. Add those down. -2 plus 2 gives me 0. Beautiful, that's what we wanted to see. Now we have our quadratic of x squared plus 3x plus 2, but multiply that by this factor right here, which we just found out was a factor. We keep them together because this whole entire thing is this polynomial right here, and we're trying to graph it. In order to graph it, I can't graph this yet. I need to mam it first. So remember, when you're mamming, you take your last one, pull it to the side. 2, my factors of 2 are 1 and 2. So for my first m, I know x times x is going to give me x squared. For my second m, I know 1 times 2 is going to give me 2. But how do I take 1 and 2 and get 3? Add 1 plus 2. Plus 1 plus 2. So don't forget to pull this extra 1 down as well. So now I have a degree 3 polynomial. And when I'm finding my roots, set each of these equal to 0. So I'm going to get x equals -1, -2, and +1. Okay. So these binomials right here, they represent this polynomial right here. Let's plot our roots at -1, +1, and -2. Okay, our key features. What's our degree? We can find our degree in 2 different ways. In standard form, my degree is my leading coefficient, my leading term right here. In factored form, it's the number of x's we have. I have 3 x's in factored form, and I have a leading degree of 3. So my degree is 3, meaning it is odd. What's my y-intercept? When I'm in my y-intercept, if this is my polynomial, my y-intercept is my last term. So my y-intercept is -2. Let's plot that guy. Max and min. We don't have max and mins we're going to have yet, but I'm sure you can guess. Roots. Oh, we just wrote them right here. So x equals -1, -2, 1. And behavior. Are we positive or are we negative? We are positive because there's no negative right here. So we are positive, odd, which means we look like this. So as x goes to infinity, f of x goes to infinity. So we're going to end there. As x goes to negative infinity, f of x is going to go to negative infinity down there. So we start down here, go up, turn around, come back down, cross through, and go up. So that is what our graph should look like when we sketch it. Let's do another one. Looking at this guy down here. Sorry, this is the exact same thing you have. My hole punch went through it. So we need to synthetically divide this one so we can graph it. I'm going to pull, this is a -3, so it's going to become a +3 down here. I have an x cubed and then just an x. An x cubed tells me I should have 4 terms, but I don't have all 4 terms. I am missing an x squared. So we can write on here, missing x squared, so use placeholder. So really, we're going to be using the polynomial x cubed plus 0x squared minus 7x minus 6. Now let's grab those coefficients. There's a 1, there's a 0. That's my placeholder. -7, negative 6. Pull 1 down. 3 times 1 gives me 3. 0 plus 3 gives me 3. 3 times 3 gives me 9. Negative 7 plus 9 gives me 2. 3 times 2 gives me 6. Add those together, I get 0. Beautiful. That means that this is a factor. Okay. But I need to now take this one, and if it was an x cubed, we can now write it as an x squared. So x squared plus 3x plus 2 times my factor x minus 3. In order to be able to graph it, we have to MAM it. Okay, so we can pull this guy over here, and we're going to get 2. 1 times 2. We're going to get x, and then you're going to get plus 1 plus 2. Don't forget to bring your x minus 3 down. And your roots, set them equal to 0 and solve for your roots. So x equals negative 1, negative 2, and 3. Let's plot those. Negative 1, negative 2, and positive 3. All right, so this guy, if my degree is 3, it doesn't matter if we had to have a placeholder, my degree is still 3. What's my y-intercept? My y-intercept is my last term that doesn't have an x attached to it, so it's negative 6. Plot that guy. Max and min. We will do it after we plot the graph. Roots, let's write them down. X equals negative 1, negative 2, and 3. End behavior, we are positive, so it's going to be a positive odd, kind of like how we had above. So as x goes to infinity, f of x goes to infinity. As x goes to negative infinity, f of x goes to negative infinity. So let's sketch this guy. I have 1 max and 1 min. 1 max, 1 min. What questions do you have? If you have any questions, write them to the side right here. Oh, you can't even see. If you have any questions, please write them to the side or raise your hand and I will come over and help you if you're watching these in class. All right, this next one is a little bit bigger, so I'm going to make a different video for this one. Check that.